Thanks for coming, everybody. We're getting ready to kick off the security panel, so hopefully that's what you intended to see here. My name's Gary Golem. I'll be moderating the panel. Quick sort of 10-second background on me is I got into the security space in the late 90s, actually in the 5th security startup that I've been involved in right now. So 2 of those co-founded. One was kind of voting stock member, and the other 2 served as kind of director, research, development type positions. Been kind of focused on R&D for the most part throughout my career, a bit of consulting and kind of getting involved in intrusions and breaches and things like that. 2 of those companies have been very heavily focused on I'd say data-focused solutions, using large amounts of data to do fantastically interesting things. All that being said, I am definitely the least impressive and interesting person on this stage right now. I've actually been really excited about this panel. We were talking about this earlier, I've never seen a lineup of folks like this talking about this topic specifically, even at security conferences. So it's actually a really unique lineup and set of people up here. So I'm excited about the conversation we're getting ready to have. Format we're going to go through is each person's going to stand up, kind of give you a little bit of introduction to themselves, their background, some of the work they do, some of their points of view and perspectives on security, the challenges we have, and really how data can contribute to solving some of those challenges. And then from there, we're going to go into a question-answer format. I have a number of questions in mind that I've been looking forward to asking everybody up here and seeing what people think. Of course, open mic and happy to take questions and see where the conversation goes from there up until the end of the time, which is scheduled for about 3 o'clock right now. So without further ado, I want to turn it over and let everybody introduce themselves. I know you guys can do a much better job than I could. So, Raffi, go ahead.
All right. Do you want me to do the presentation or?
I'd say wherever you're more comfortable. Yeah, maybe do that there.
Good afternoon, everybody. So I want to give you a quick introduction to the topic of security and give a little bit of a framing also for the panel afterwards. So I prepared a few slides here. This is just a disclaimer. But to define what security is, I'm going to take a very, very simple approach. I'm going to look at 2 areas in security, prevention and detection. And it's kind of one way that you can slice up the different security tools out there, the methods that we have. We have a lot of prevention tools like firewalls and antivirus that try to prevent the attackers. And then you have detection tools where we're trying to, after the fact, when something is happening, we're trying to detect if something bad is going on. And I want to look at these 3 time slots here, the past, the present, and the future quickly. So if we look at that, in the past, prevention has been sort of focused on one entity, right? We had a firewall that's trying to block the traffic. Maybe you had an intrusion prevention system. They were sort of isolated. You might have an antivirus that just sort of lives on a machine and looks if something bad is happening, and if so, then it will block that binary or that execution there. On the detection side, if you look in the past, we haven't really done that much. We basically just collected the data. It was mostly driven by compliance. You wanted to look at it, bring the data in, and maybe search through it for forensic purposes, but it was not really very mature. Now, in the present, we have changed these things quite a bit. We're starting to look at solutions where we're actually talking between these different devices, right? The firewall actually starts talking to the endpoint. If the endpoint is compromised, it will actually tell the firewall that, and the firewall will block it. We have sort of cross-entity intelligence. We're not just analyzing firewall logs, but we're looking at the whole thing. We're looking at proxy logs. We're looking at IPSs, or intrusion prevention systems. We're looking at application logs and OS logs and try to correlate all of that to find if something bad is going on. So on the detection side, we're using big data technologies. We have been building this stuff for the last 15 years probably. We've been dealing with a large amount of data. We're dabbling in machine learning, and I think this is going to be a perfect topic we're going to discuss later a little bit as well. I think we all have interesting opinions in that field. I would say we're still dabbling in machine learning and sort of finding signals in the noise that really matter. And there's many, many challenges we're still looking at in the detection side. Now, going into the future, well, we would like to predict, But predicting an attack is not that easy. I'm not even sure how I would go about that. Maybe another topic we can look at. But I think what I'm predicting for the future here, what's going to happen in security, is that we're going to have more and more machine-assisted insights. So I don't believe that machines will be smart enough to flag all the bad things happening out there, but they will help an analyst, a human, actually look at the stuff and understanding where bad things are going on. I put UX focus there, UX standing for user experience. I think we're going to focus much, much more on how the user interacts with these systems, make it easy for everybody. It needs to be transparent. Analysts that are looking at screens today, they're going to get a much nicer experience. Now you see on prevention there, I have an empty slot. Well, if we look, I believe what's going to happen is that from the detection, we're actually going to learn from that and then do enforcement that way. And we're seeing that now already happening a little bit, that more and more of what we look at, we actually start preventing things. Now, looking at that, you basically see there's a shift sort of from traditionally from prevention, going to detection, and then closing the loop again with the prevention part. So that's kind of an interesting trend that I find in security. And one of the reasons for that is, if you look at attacks today, back in the day, if you remember some of the worms out there, like an MS Blaster or a SQL Slammer or something, they were just going blanket. They were attacking the entire internet with the same attack. So once we found it in one place, we could write a signature, and we would detect them everywhere again. Today, 70 to 90% of attacks are specific to your organization. So what you're going to see in your network is not what your colleague is going to see on their network. So that's why we need an attempt to look at this stuff specifically. All right, so that's just kind of my mindset for going into this. Now, given that a big part of security in my definition here is really detection and data analysis, I want to look at security as sort of gaining insights. I have a large amount of data. How do I find what's going on? And for that, I need data. I need some analytics on the data to find the interesting stuff. And I'm going to motivate why visualization is an important part in this. So visualization is something like this, right? I give you a large amount of data. And instead of you having to go and run some SQL queries to do some distinct counts on the different fields and understanding what's even in the data, you want to have a visual and interactive way to go through the data and analyze what's actually in there. It's much, much quicker. So there we go. If we now look at the three different parts, the data, analytics, and visualization. So on the data side, to give you a little bit of a feel for what we're dealing with in security, it's basically time series data. It comes in all kinds of different forms. One of the things is that a lot of our fields, or the data has a lot of categorical data. So if you're a data scientist, you're probably doing a lot of the data science on numbers, on measures. Doing data science on categorical data is really hard because you have to find the right distance functions, and that gets very tricky. Aside from the time series data, we have contextual data. I call it that because assume that you're looking at machines talking to each other. And what you're generally seeing is an IP address connecting to another IP address. Well, I want to have context. Is this a desktop? Is it a server? Is it a web server? Well, who is logging into that desktop at what time? And what's this person doing? Is it an engineer? Is it a person that is on a performance improvement plan? All these kinds of things I want to have as context to understand what's actually happening between these two machines. And then often what happens when you're collecting this data, you have multiple records for the same thing that's happening, right? I might log into my laptop and use the browser to go somewhere, but there might be 5 different places where I collect telemetry. So I have to somehow stitch that together and build that story around it. So I have something like a transaction, but I need to somehow work with that and maybe have some fusion in there. Once I have the data collected, there's a ton of different access use cases. It's anything from search to aggregates to lookups to compute, like really distributed computing. You want to do machine learning on all of the data. So from a data store perspective, I drive the DBAs crazy generally because I say, look, I can't tell you what my users are going to look for. I don't know what the queries are going to be that you need to optimize for. I want an index on everything. And they're like, well, we can't optimize for everything, but that's what we need. We need very fast inserts, and I need fast reads on pretty much any question we're going to ask here. And I want to have one interface, please. I don't want to have 4 different interfaces, and some support full SQL, and then I go to a graph database, and well, there are some people that use some extended SQL to do that, and others use some other language to access the data. I want one language to go across everything and access it. Ideally, it's something SQL-like, but it's probably an extended version of that. So then, bunch of challenges. Collection, we have different formats. We have to parse that stuff somehow. That's really hard. Scale, obviously. Encryption, we want to make the stuff secure. Then we have privacy issues. I think in the morning talk, some people were talking about that, right? I have data centers in Germany with data from German citizens, and that data can't leave the country. But how do I do analytics on global data? All these kinds of things are pretty big problems for me right now. But then in the end, it's like, how do I find relevant insights in here? What does this data tell me? Is there an attack in there? How do I make this stuff useful? And then if I keep going my rant here, like if I build a system today that collects the data and lets me analyze it, I have to basically go out there and pull the different components. I might buy a database here, and then, oh, do I need a key value store? Or maybe I need a columnar store, and then I might also need a graph database, and then I have to have indexes and all these, so I need to run some indexing stuff, Elasticsearch or Lucene and that, and it's a mess. Can I just get a reference implementation where I shove the data in and on the end I can query? That would be great. So we have the data. Now we go to the analytics part. Let's assume we have everything solved. We can access the data. It's collected. Oh boy. We've tried so many things in security to do anomaly detection, right? I want to find where the attackers are. I want to find if something is anomalous. Guess what? Like all this, you can go and do all this data science, and basically what you find in the end are statistical anomalies in the broad sense of statistics, right? You see if there's an outlier somehow in volumes or in some metric. In the end, that's generally not a security problem. I can give you so many examples of false positives that you will find that way. So then you have to enhance these things, and it gets really complicated. So in the end, we have tried all kinds of different approaches with cohort analysis to use some clustering there. You can do some implementation of hypotheses that are finding certain types of behavior. One of the things that we generally like to look for is if you know what a botnet is, basically it's like a bunch of machines on the internet are compromised or hacked, and then the hackers are basically instrumenting them to do some harm. They can be used for sending spam or doing denial of service attacks. Generally, if a machine is infected and it's part of a botnet, it will phone home periodically to see what it should be doing. So there's sort of a beacon going out that's generally in a very regular time frame. So you try to do beacon detection. But the problem is you find these beacons in all kinds of things, in network protocols that are regularly doing these things. And that's pretty hard. I gave a whole talk 2 years ago at KDD about sort of the challenges we have in security with machine learning. And I have a couple of things here. I think probably the hardest part is distance functions. How do you define it? It's sort of fundamental on doing any kind of clustering or analysis that you have to define a distance between two things. And that's incredibly hard. And that's why I also say the simple stuff works, right? If you look at the graph on the bottom right, you can all see some outliers in there in the metrics, and then you can start drilling in and see what's happening there. Here's another example where I want to show you that, well, I can cluster my data. This is network traffic that I took. It's like a week worth of traffic. I threw some clustering algorithm over it, used some kind of coloring here. But the idea here is what you're seeing are different clusters of things. Well, ideally, one of these clusters is now my web servers, and the cluster is my mail servers, and the cluster is my desktops. But how do I know that from this? I don't. These are two basically very arbitrary or in some mathematical space, these are two axes here that I'm using to project this data into. I don't know what the axes are. They might not even be linear configurations of the original features that I had. But then understanding what these clusters are, do things really cluster together? Are all the web servers in one point here or not? So I need all kinds of things to interact with this and understand what the clustering algorithm has done. I'm going to go over this quickly here, just so that I don't take up too much time. So then okay, analytics is maybe helps a little bit. But what I would say is with visualization, we can see what these algorithms are doing to us. We can see the data, and we can hopefully get an idea of what's going on. And if we put a smart analyst, a security analyst, in front of these visualizations, we can help them understand what's actually happening underneath it. So what I try to use in my work, what I'm trying to use analytics for, is to have sort of human augment or a machine augmented analysis and then bring it back to the human to let them understand what's really happening. And why visualization? Well, I put this example here together. I'm not sure if you're familiar with parallel coordinates that you're seeing here on the right-hand side. Basically, what you're seeing is I took a firewall log file, and each of the lines here, the vertical lines, is one of the fields in the data. So on the left-hand side, you have protocol, and that's TCP or UDP in this case. That's why there's only sort of 2 points. But then you have the port numbers going from 0 to 65,000 on the top. And a line in here is basically one log record. So if I had a TCP connection on some port from some kind of a source network to a destination network, there's a number of flows that were associated with that. There will be one line in here. So you see certain patterns in here. If I gave you a log file of this, and I ask you, what is this? It would take you all these queries on the left-hand side, and probably many, many, many more, to understand what the data is about. But the visualization, at one glance, sort of answers all of these different queries already. And if you're making it interactive, you can even select certain points in here, and then it will highlight certain parts, which would be a whole bunch of other queries, again, that you would have to run to understand what the data is about. So visualization is a great way to let you drill in and understand what's actually happening in the data. Now, I'm pretty sure if I told you, well, just go and visualize your data, you'd be like, but hang on, there's so many challenges. I only put a couple on here. The first is obviously, well, I have terabytes of data. How do I visualize that stuff? If you have done this before, generally what happens, you get the hairball. There's nothing you can actually make out anymore. Well, there's one sort of approach that I've been following in the last years very heavily. It's something that Professor Schneiderman basically coined. It's this mantra where he says, look, you have to generate an overview first to sort of understand what the data is about. Then you zoom in and filter. And you might move around. Maybe you go some overviews again, and you zoom in again. And then at some point, you want to actually have the details on demand. You want to look at the raw records. Because often, this visualization gives me sort of one projection of the data, one angle of the data. I don't necessarily know all of what is actually going on here. So being able to go back to the raw records is very important. Now, building a system like this is actually not that trivial. And just this mantra sort of dictates a whole bunch of requirements for not just the front end to the visualizations, but also to the back end of what we need to be able to do with the data. The overview, we need some aggregates. We need some summaries. So we need a data store that supports that. Then we need a data store that supports the zoom in, so basically going into a sliver of the data and giving us analytics on all of that. It's like distinct counts and all these kinds of things. And we need to be able to go back to the raw records, the original data as well, from those summaries. So you need to enable all of that and make it interactive. So a user is actually clicking on this stuff. They don't want to wait 2 minutes. They don't want to wait a minute even, right? So how do you make that fast? And then I think I'll leave it with one more challenge. Once I actually find something in here, visualization is great if you don't know what you're looking for. So the unknown unknown. But once I know about it, visualization is probably the worst thing you can do, because like, why don't you automate it? Just write an algorithm or a rule or something that will catch it again. So how do you translate your learnings into something that automatically catches this stuff in the future? And here's just a couple others. Visualizations, I'm not going to go into detail of what they are, but this is some of the stuff that we're dealing with when we're looking at the data. It can actually be really pretty. Here's a couple other examples. On the left-hand side, you see logins to systems, and these are only the top 10, in terms of amounts of logins, these are the top 10 users, and red is failed logins, and the blues are successful ones. And you see very interesting things already in here. There's a big blue arrow there. Why is this guy constantly logging into a system? That needs to be some automated process or something. And what are these big red arrows in here? That seems to be something that constantly fails to log in somewhere. So there's interesting questions this thing will pose. And then the right-hand side is actually the same data. It's just slightly different layout there on different entities. All right. That's basically what I'm doing in my day job. So at Sophos, we are sort of building these kinds of systems where we connect the detection and the prevention pieces, and the entities are starting to talk to each other. So the endpoint is actually talking to the firewall. The encryption product is talking to the endpoint. So when the endpoint is compromised, your encryption keys are getting shredded. You can't do anything anymore. So that's where we're going towards. And it's really making systems for non-experts. I need you guys to be able to understand what's happening and ideally just be secure and know that everything is fine. And with that, I'm going to stop here and let my fellow panelists introduce themselves.